So the next part of the first chapter of algebra is factorising. So factorising is the opposite to expanding. Okay, so if you were asked to expand something, the question would have brackets. Okay, and the idea is that you're removing them. But if you're asked to factorise, the question is going to start with no brackets, and you're trying to bring the brackets into the answer. Okay, so they're the opposite operation to each other. And there's 4 different ways we're going to look at factorising. Now there's 2 sections to this. So the first section, I've obviously started with the easier parts, and I'm going to do all 4 methods, but the questions are going to be easier. And then the next part of factorising again is the same 4 methods, but the examples will be harder. Okay, so going to see this a lot throughout all of the maths course. So highest common factor, so HCF, you would have seen this in junior cert maths as well. So it's taking out what the terms have in common. So if we look at x squared plus 5x, we have 2 different terms. Okay, notice that they're not like terms. Also notice that there's no equal sign, so we're not trying to solve here, we're just rewriting these in a different way. So factorising would be rewriting the expression in a different form. So if you look at these 2 terms, what they have in common is an x. If we've taken x from the first term, we're left with another x, because x multiplied by x gives x squared. And if we've taken x from the second term, we're just left with 5, and that's your final answer. Okay, so it is that straightforward. So x times x is x squared, x times 5 is 5x. So notice, if you multiplied out the answer or expanded the answer, you should get what you started with. Okay, so they're the opposite to each other. Same idea here, a squared minus 11a. So what they have in common is an a, and we're left with a minus 11. A times a is a squared, a times minus 11 is minus 11a. And here they have an x again in common. X times x gives x squared, x times minus 14 gives us minus 14x. Okay, so very straightforward for highest common factor there. Moving on to the next type of factorising is factorise by grouping. Okay, now in each of these examples you can see there's 4 different terms this time. Okay, so 4 different terms. They do not have something in common. So yes, these 2 have something in common, these 2 have something in common, these 2 have something in common, these 2 have something in common. But if you notice, there's not the same letter in each of the 4 terms. So we actually can't use highest common factor here, but we can use highest common factor if we group the terms. Now, the easier examples, the terms will already be grouped. So you can see both of these have an A, and you can see both of these have a B. So we're going to treat them separately, but try keep it all together at the same time. So these 2 have an A in common. So I'm going to take the A, and what's left inside the brackets would be P plus Q. And then here we're going to take out the plus B, and we're also left with P plus Q. Now in factorise by grouping, you should notice that the 2 brackets should always be the same here. If they're not the same, then you've made a mistake somewhere. Okay, so that's a good checkpoint for you. If they're not the same, you've made a mistake somewhere. So to finish this off, we write our final answer with the 2 outside terms in one bracket together. So the A plus the B times the P plus the Q, and that's our final answer. Now, if you remember at the end of the last video, you were expanding back-to-back brackets. So if you multiplied this answer, okay, using your arrows, you would end up with what you started with here. So it's the same idea. Again, they're the opposite operations to each other. Okay. So next example, we've AC minus AD. Okay. They have an A in common. And we've minus BC plus BD, so they both have a B in common. So we're going to take out the A here, and we're left with C minus D. And here we're going to take out the minus b here, and we're left with c minus d again. So just be careful here. I've taken out the minus b. Minus b multiplied by c is minus bc. And then minus b by minus d, minus by minus gives the plus that we're looking for. And BD is BD. So just be careful with the signs there. To be honest, mostly where we see problems is from multiplying signs or kind of making small mistakes using your signs. So our final answer again here, we've A minus B, the two outside terms together, and C minus D, and that's our final answer. Now keep in mind, again, if you were to multiply these two back-to-back brackets, you again would end up with the answer that you had here. Okay, another example here, 2xor minus rs, so I can see both of those have an or in common, and here both of these have a y in common. So I'm going to take out the or, and we're left with 2x minus s, okay? Taking out here, we have to look at the numbers first of all. So the highest common factor of 10 and 5, so the factors of 10 is 1, 2, 5 and 10. Factors of 5 is 1 and 5, so the highest common factor would be minus 5, but they also have a y in common. So it always has to be taken out as much as you can, okay? So that's why don't forget we're looking at numbers and we're looking at letters here. So if we've taken out minus 5y here, 5 times 2 gives us 10, so we're left with 2. And the variable left over here is x, okay? And then here we've already taken out the 5 and we've already taken out the y. Minus by a minus again here gives us plus, and we're left with an s. So notice again, the two brackets are the exact same. So your final answer here is or minus 5y and 2x minus s. Now in the last example for this section here, we've pm plus nq plus np plus mq. Now, if you notice there, I've underlined these, and I shouldn't have, because the PM and the NQ don't have anything in common, and the NP and the MQ don't have anything in common. So I'm going to rewrite these so we do have something in common. So if I look at that first term, PM, I'm going to match that with NP. So plus NP, because both of those have a P here. Okay, and then I'm going to take the MQ, so plus MQ, and I'm going to take plus NQ here. Okay, so they both have a Q in common. So we can factorize by grouping again. So we're going to take out P, and we're left with M plus N, and we're going to take out our Q here, and we're left with M plus N. Two brackets are the same, and just notice the reason I put the MQ before the NQ was because I knew there was going to be an M and an N in the same order here. Now if I had N plus M here, it actually wouldn't matter, but you just have to make sure the signs are always the same. So we didn't run into the problem here, but further on in more challenging examples you might run into a problem. So just be mindful of that. So our final answer here, we've P plus Q multiplied by M plus N, and that's our factorise by grouping. So just the method is going to be the same. As the examples get more difficult, the method is still going to be the same, but just the questions will become a little bit more challenging with what's in the terms, and our signs obviously get a little bit more complicated as we move on. Okay, difference of two squares. Okay, so by squares it means something squared is what we're talking about here. Now each of my examples you can see I have an x squared, a b squared and a y squared. So difference of two squares, you're always going to have a squared term, you're always going to have a negative sign, And you're always going to have a perfect square number that can be rewritten as something squared. Okay, so if we look at this example here, we've x squared minus, we're going to rewrite 9, so the number is now something to the power of 2. And we know 3 squared is the same as 9. Okay, when we have everything squared and a negative sign in between, we rewrite these as back-to-back brackets, x minus 3, x plus 3, and that's our final answer. Okay, difference of 2 squares. So just remember it's different signs in the answer. Always will be. Okay, now again, because we're factorising, if you wanted to check if your answer was correct, you would multiply out those back-to-back brackets and it would give you the question you started out with. Okay, so it's the exact same idea here. Next part, we have b squared minus 25. So we're going to rewrite that as b squared minus 5 squared. Okay, and using our back-to-back brackets, we've b minus 5, b plus 5 as our final answer. And again, if you multiplied that out, you would end up with b squared minus 25. Okay, and the last one, we've y squared minus 121, okay, is the same as 11 squared. So we have y minus 11, y plus 11, and that's our difference of 2 squares. And the last part, okay, is our quadratic trinomials. Okay, quadratic trinomials means there's going to be 3 parts or 3 terms in this question. Okay, quadratic, you're always looking for your squared term again. So it's going to be written as ax squared plus bx plus c. Okay, so an x squared term, an x term, and a constant. Okay, so the x's here are variables. The a, b, and c are just numbers. Okay, the x squared and the x are variables. Now, I've written there about the sign of the constant. Okay, now the constant should always be at the end, and it's obviously just a number on its own. Okay, now we're always looking for that sign of the constant, because if the sign of the constant is positive, okay, then the answer in brackets is going to have the same signs. Okay, so our answer in quadratics, when we're factorising quadratics, our answer is always going to be back-to-back brackets. So if the sign of the constant, okay, so if the number at the end is positive, that means the signs in the back-to-back brackets at the end are always going to be the same. Okay, and if the sign at the end is negative, then our signs are going to be different. So either a plus and a minus, or a minus and a plus. And that's really, really important. That's something that people tend to not know or to forget. And really, it's a good checkpoint in all of these questions. Okay. Now, what we're looking at here, these are the most straightforward quadratics you will see. So we're able to solve these just using back-to-back brackets straight away. Okay. So x squared can be factorised by using x times x gives me x squared. Okay. 9 can be factorised by using either 1 times 9 or 3 times 3. Now you're always going to be picking the factors that will add or subtract to give you the number in the middle. Now if we look at 1 and 9, well, if we add them, 1 plus 9 gives 10. If we subtract them, 9 minus 1 gives 8. So we're not going to get a 6 from using 1 and 9. So 1 and 9 doesn't work. Okay, so the factors here are going to be 3 and 3. So 3 times 3 gives 9, and 3 plus 3 gives 6. Now remember this sign of the constant. Okay, so here it's a positive. So we're looking for either 2 pluses or 2 minuses. And because we're looking for plus 6x, it's going to be plus 3x plus 3x gives us plus 6x. Okay, and that's our final answer. We're not solving here, we're just factorising. There's no equal sign, so we don't go any further at this point. If you were solving, so if there was an equal 0 here, then you would have to continue. But because there's no equal 0 yet in these questions, we are just factorising, and that's our final answer. Okay, question 2. We've our back-to-back brackets again. We've x times x gives us our x squared. Factors of 14 we know is either 1 times 14 or 2 times 7. Now remember, we're trying to get the number that's in the middle here using those factors. So 14 and 1 is 15, or 14 minus 1 is 13. So we know that's not going to work here. So we're left with our 7 times 2 gives 14. And if we look at the sign here, we have a minus 14. So remember, the sign of the constant, when it's negative, means our answer is going to either a plus and a minus, or a minus and a plus. Now we need to be more careful here when the signs are going to be different, because you have to decide which number should get the positive and which number should get the negative. So if we did plus 7 and minus 2, we will get a plus 5, which is what we're looking for. And just to show you what would happen if we gave the negative to the 7, so minus 7 plus 2 gives us minus 5. And we're not looking for a minus 5 here. So the positive has to go with the 7, and the negative has to go with the 2 to give us 7 minus 2 gives us plus 5. Okay? So 2 different examples there, noticing that we have our positive 9 and our negative 14, and it is relevant here when it comes to our signs at the end. So the next one, 2 negatives here, so it's going to change our answer a little bit further. So back to back brackets again, we've x times x gives us our x squared. Factors of 63, we've 1 times 63, 3 times 21, 7 times 9 gives us 63. I'm just thinking, is that it? 4 doesn't go, 5 doesn't go, 6 doesn't go. Yeah, I think that's it. So we're trying to get a minus 2 here. You get very used to the numbers, you'll see them very quickly. 1 and 63 is definitely not going to give us a 2. 3 and 21 is not going to give us 2, so it has to be a 7 and a 9. Sign at the end again, okay, is negative. So we know if it's negative, our sign either needs to be positive, negative, negative, positive. Okay, so if we're looking for negative 2 here, we need to decide which number is going to have the negative and which one's going to have the positive. So if we do minus 7 plus 9, minus 7 plus 9 is going to give us a plus 2, and plus 7 minus 9 is going to give us a minus 2. Plus 7 minus 9 is going to give us our minus 2. So our positive now goes with the 7, our negative goes with the 9, and that's our final answer there. Okay, and the last example, okay, we've our x squared minus 15x plus 56. So we've our x times x gives us x squared. Factors of 56, 1 times 56, 2 times 28, 3 doesn't go, 4 does go. 4 times 14, and 7 times 8. Okay, again, you could be using your calculator to figure out all of those factors. Sorry, is my screen gone dead there? Yeah. So 1 times 56, 2 times 28, 4 times 14, 7 times 8. You could use your calculator for those. And again, you get very familiar with what does and doesn't work. 1 and 56 is not going to give you 15. 2 and 28 is not going to give you a 15. 14 plus 4 is 18. 14 minus 4 is 10, so that's not going to give us 15. and then a 7 plus 8 will give us a 15. So it's our 7 and 8 that will work here. Sign of the constant, okay? So because it's positive this time, it means that your signs are either going to be a plus and a plus, or a minus and a minus. Plus 7 plus 8 gives us plus 15. We are not looking for a positive 15, we're looking for a negative. So it's going to be minus 7 minus 8 gives us minus 15, and that's our final answer. Okay, so if we look at them questions there, you'll notice that they're actually very straightforward in terms of what we're going to look at. But just to be clear, the 4 different methods that we looked at there: highest common factor, difference of 2 squares, factorise by grouping, and quadratic trinomials. They're the same 4 methods we look at in the next video, but just the level of questioning will get a little bit more challenging. Okay.